Okay, in this section we are going to introduce the idea about polynomials. And today we're going to add and subtract, and ultimately we'll actually solve a polynomial equation. We've got to go over a little bit of vocab. First thing is a term. Terms are separated by plus and minus signs. So for example, if you saw 2x plus 3, you would say that's two different terms. As opposed to if you had 4a squared, b cubed, c squared, d to the fifth, and so on, that's still just one term. So the difference is, are they separated by plus and minus signs? And then if you have a monomial, that is simply a polynomial with one term. And then, as you might have guessed, that means a binomial is two terms. A trinomial, like a tricycle, is three terms. So the big cloud that hangs over the umbrella over everything is that these are all polynomials we're talking about, but more specific to the word than polynomial can be monomial, binomial, or trinomial. And then we have to talk again today about like terms, because that's going to happen with we're simplifying polynomials. Remember that like terms have to have the same variable, and that variable has to be brought to the exact same power to be combined. And some of the easy things you'll see with that would be something like 3x plus 7 plus negative x minus 5. Here you have different sets of terms that are considered like terms. You can add the x's together, so 3x and negative 1x would make 2x. Positive 7 and negative 5 would make positive 2. And like everything else in mathematics, after you learn the easier stuff, it starts to get a little bit harder. But with polynomials, there's nothing too bad about it. So this is a typical adding two different polynomials together. These happen to be trinomials. So you're going to look for the like terms and combine them. We have 3x squareds and 2x squareds, so we have a total of 5x squared. We have 4x and negative 7x. 4x minus 7 is negative 3x, and negative 5 and positive 10 is positive 5. Sometimes you'll see these problems set up via subtraction, and you got to just be a little bit more wary about that, because that subtraction sign has to apply to every single one of those terms in parentheses. So what I normally do, so that I don't make a careless error, is I'll change that negative sign to a positive, and to do that I have to take every term in the parentheses and change their polarities, which I've just done for you. And then you can look at them, and it's a little bit easier to combine them. So you know 5 and negative 2 makes 3. Negative 6 and positive 5 is negative 1. Negative 9 and positive 21, I believe, is positive 12. And the only other problem we're going to deal with polynomials is solving a polynomial equation. So you've solved equations like this before. In this case, we've got, again, to distribute a negative sign throughout the parentheses, combine like terms on the same side of the equation, get our constants away from our variables, so we're going to add 3 to both sides, and divide both sides by 4, and we can just leave it as 4/11. So we don't have to worry about putting that as a mixed number or how much that equals or a decimal. We just leave it as a fraction. It's easier that way. And then let me give you a really challenging one, and this will be the last one we do for this lesson. So we've got a lot of stuff going on here. So let's start by distributing this 2x, but we got to remember we're distributing a negative 2x, so the negative is going to go along for the ride. So going back to our rules of exponents, negative 2x times x would be negative 2x squared, and then negative 2x times negative 1 becomes a positive 2x. That's going to equal 3 times x is 3x, negative 2x times x is negative 2x squared, and then distribute the negative sign through both terms. Let's combine terms on the same side. Okay, so we're going to subtract negative 2x from both sides. Those cancel. The two x's cancel. And so what we've got going on here is an example when you have an equation where anything will work. We'll rewrite the example all real numbers as a solution, because no matter what you plug in for x, if you go to simplify an equation like this and you get an answer of a true statement, that just means that the entire statement is true. All real numbers will work as a solution for x. See ya.